From the possible existence of parallel universes to what happens inside a black hole, today we look at the biggest mysteries in physics. Number 11. Force unification. One of the main things that scientists who study quantum mechanics are trying to solve is the question of how the four fundamental forces were created and whether or not they can be combined. Some renditions of the Big Bang Theory are built around the idea that all four forces, gravity, the strong nuclear force, the weak nuclear force, and electromagnetism, all came from the same source and were perhaps one in the beginning. Using gigantic and powerful particle accelerators, like the Large Hadron Collider, physicists have been able to combine the strong and weak nuclear forces and electromagnetism. This took an insane amount of power, measuring more than trillions of electron volts. Though many consider it impossible, it is believed it would take even trillion times more that power if they wanted to merge gravity with the other three. Number 10. Parallel universes. There are some scientists who still maintain that space-time is curved, but the latest data that has been collected by astrophysicists suggest that time is flat and stretches into infinity. Meanwhile, when looking at the small side of things, the rules of the quantum level say that there are only so many possible formations for particles. In other words, while time is infinite, what can make up a universe is finite. These theories, when combined, bring up the possible conclusion that our universe is only one out of a potentially infinite amount of parallel universes. If this is true, there still may never be any way to observe these parallel universes, let alone prove it. If there are infinite universes, that would mean that there are more than likely universes that are exactly like our own, except for small changes in detail. On the other hand, it would also mean that there are universes that are the complete opposite and extremely different from ours. So much so that it would be impossible to comprehend. Now, which idea is a scarier thought? Number 9. Light from sound. If you shoot sound waves in water with enough force, you can actually create bubbles in the water by displacing the water for a moment. When these bubbles collapse, they do so with an extremely intense amount of energy, and this energy, for fractions of a fraction of a second, creates a flash of light and heat upwards of thousands of degrees. What's the mystery behind this? Well, physicists have no real explanation for how or why this occurs. It's almost as if the light appears from thin air, which we know is impossible. Some theories that have been put forth are that some sort of electrical discharge is created during the bubbles bursting, or that there is a type of nuclear fusion reaction occurring. But so far, they have no actual evidence to back up any of these claims. This unique event can actually be created naturally by a species of crustacean, pistol shrimp, who have a claw that creates bubbles to stun their prey. Number 8. String theory. To establish and prove a theory of everything has long been the holy grail sought after by physicists, from Isaac Newton to Albert Einstein and beyond. One such theory that has become a leading candidate to explain everything is that of string theory. String theory posits that everything in the universe, when reduced to its simplest form, is made up of one-dimensional particles called strings. These strings vibrate and interact with each other, forming the building blocks for everything, such as light, gravity, and matter. Though scientists have found evidence of quantum particles that are essential to the theory, there is currently no way to see these infinitesimal strings, or prove they exist by other means. And there may never be. Number 7. Into darkness. Astrophysicists and astronomers have studied black holes for years. They have an idea how they form and can estimate their potential power, but we may never know what goes on inside a black hole. These monsters that form from collapsed stars are so powerful that not even the fastest known thing in the universe, light, can escape their clutches. So as you can imagine, this makes studying what goes on inside a current impossibility. Quantum mechanics postulates that the quantum information of something, or evidence of what has happened or will happen to a particle, cannot be destroyed. However, if a particle is dropped into a black hole, the forces are so strong that in theory the particle will not be able to escape. Therefore, its information is destroyed. In order to try and solve this puzzle, which is known as the information paradox, physicists like Stephen Hawking have gone through piles of chalk and pencils. The best solution they can come up with is that the information never really gets fully sucked into the black hole, but instead sits stuck on the black hole's event horizon. Number 6. Time. Why does time go forward in seemingly a straight line? Well, because the universe is actually descending more and more into disorder and chaos every moment. The process is called entropy. There is evidence to suggest that when the universe was first formed, everything was much more organized and balanced. But because there are more chaotic particle formations than those that are balanced, and the chaotic formations are constantly disrupting the balanced ones, change occurs, therefore time. What has scientists the most befuddled about entropy is the fact that just after the Big Bang, when all the matter and energy in the universe was packed tightly together, how was the universe at its most organized state? Most physicists believe that the secret may be unlocked if we can only find out how the 4 fundamental forces were once combined. Number 5. Dark energy. For the last couple decades, dark energy has appeared so often in discussions on physics that you would think it is at least a partially known commodity. The truth is, as of now, dark energy only exists in theory. It was first proposed as a solution to the problem: if gravity is constantly pushing space-time in an inward direction, then why is the universe expanding at a more and more rapid rate? Astrophysicists couldn't find any visible or obvious reasons for this, so they were forced to introduce the dark energy idea, so they could continue on with their calculations instead of just stopping and waiting for hard evidence. As the years have passed, several new theories have hinted towards theoretical dark energy being a legitimate answer to expansion. If dark energy does exist, modern theories and hypotheses suggest that it could possibly make up more than 70% of the universe. Number 4. Dark matter. Dark matter goes hand in hand with theories on dark energy, and just as with dark energy, it exists mainly as an idea. Dark matter does differ from dark energy in the fact that there are a few more slivers of evidence that point to its existing. The idea of dark matter came about when astrophysicists observed some unknown mass which didn't put out or absorb any light particles. They saw that this matter was causing slight changes to radiation, known matter, and other parts of the universe via gravity. These instances were observed mainly on the outer edges of the universe and may be what gives structure to everything. Some scientists speculate that dark matter may flow and weave its way throughout the universe, causing small chain reactions along the way. It is theorized that dark matter makes up over 80% of matter in the universe. Number 3. Gravity. Gravity is all around us, affecting us in everything we do in our daily lives. Yet the powerful force that keeps us clinging to this rock we call home is still one of the biggest mysteries in all of science. The other 3 of the 4 fundamental forces, weak nuclear, strong nuclear, and electromagnetism, all have particles from which their powers and energy can be attributed, but not gravity. Physicists know that gravity has to be made up of something and have even given this theoretical particle a name: the graviton. There are many theories about what the graviton might look like and how it acts at the quantum level, but no one has ever found any concrete evidence of their existence. One of the main problems is that scientists aren't even sure if gravitons interact with matter, like the other forces do, or if they have a mass that is measurable in the physical realm. If they do exist, they are believed to be one of, if not the smallest particles in existence. In string theory, it is proposed that gravitons are merely closed energy loops, but so far the math hasn't added up. In one or more of the interesting theories, some physicists have proposed the idea that gravitons only exist in a yet-to-be-discovered dimension. Number 2. Matter versus antimatter. Why is there less antimatter than matter in the universe? Is basically an astrophysicist's fancy version of the question, why are we here? But on an even deeper level, as it really is asking, why is anything here? Scientists know that antimatter exists and that it is the exact bizarro version of matter acting in the precisely opposite manner. What they don't understand is why in a universe of equal and opposite reactions would more matter be produced from the Big Bang than that of antimatter. We know for a fact that there is more matter, because if they were equal, they would cancel each other out, so that neither would exist. But that obviously didn't happen because we are here. So, ipso facto, there is more matter than antimatter. Number 1. The end. We all know that most evidence supports the theory that our universe is currently expanding, but what happens next is the subject of some of the biggest debates in the world of astrophysics. Most astrophysicists agree that the universe will come to an end one day, but they are still greatly divided on how this will happen. There are 3 prevailing theories on the events that would bring about the end of the universe. The first cosmological model of the end of the universe is dependent on an open-ended concept of space. In this model, everything will continue to expand and accelerate until everything becomes unbound by gravity and isolated, aka the Big Freeze, where life would be unable to exist in any form. After this, the acceleration would become so strong that even atoms would be torn asunder, and everything would cease to be. This is called the Big Rip. The second model is fairly similar to this one, except instead of open-ended space, the universe exists on a flat, infinite plane. The results would be similar. Everything would expand until it stopped, or it would continue accelerating until it was torn apart. The final model is based on a closed concept of the universe in which space-time is shaped like a sphere that encases everything. In this theory, there are 2 possible outcomes that are dependent on whether dark energy exists. If it does exist, then a closed universe in this form could potentially expand forever without consequence. If dark energy doesn't exist, the universe would eventually stop expanding because of the time-space barrier and then begin contracting, causing what is called the Big Crunch. The Big Crunch could possibly end in everything being so consolidated that it would cause another Big Bang and start the process all over again.